It is nothing new that smart homes produce their own energy from renewable sources. Solar energy, particularly, is very popular. Many smart homes are already equipped with solar collectors. Whenever the sun shines strongly enough, the solar cells produce electricity, day by day. Most of the energy is produced in the daytime, when there is no one at home to use it. Thus, 3/4 of the available energy are lost. In the evening, when the sun has set, no energy is produced. But just at that time, most people are at home and need energy for their devices. This is why giant batteries have become part of these smart home concepts. They can charge when energy is available and can provide this power when the sun is down or not shining strongly enough. During times of low energy production, the battery can power domestic devices. In this way, it can compensate the variation in the availability of renewable energy, which made complete energy self-sufficiency impossible in the past. But what does that mean for the residents when all of a sudden all of their electric devices have to share one giant battery? The residents will need to ask themselves completely new questions, like can I use my hairdryer and my toaster tonight if I will need the electric kettle tomorrow morning? Of course, they could try to estimate or calculate by hand, at least when only 3 or 4 devices have to be considered. But in average modern households, there is a huge number of electric devices and they all have different consumption characteristics. Furthermore, there is the variation in the availability of renewable energy. And in the end, the energy management inside a smart home with a battery is way too complex for most residents. This is the starting point for WATTIME. WATTIME is a software and user interface concept which enables easy energy management for the residents. In short, WATTIME collects data via the smart home infrastructure. Production data of the solar collectors, weather forecast data, status of the battery, as well as usage and consumption data from any device that can be connected to an outlet inside the smart home. From this data, WATTIME predicts if enough energy will be available for the residents' activities, if there are excesses of energy, or if basic needs are at risk because of energy deficits. In conflicts, the residents can use WATTIME's planning interface to design energy scenarios that fit various situations. Let's take a closer look at WATTIME's interface and features. The interface consists of 3 main areas. In the timetable, the user can design usage scenarios through an editable device list and a horizontal timeline. Yellow flexible rectangles mark planned runtimes for each device. White diagonal lines represent kilowatt hours. Every diagonal line that reaches the top of its rectangle stands for 1 kilowatt hour. Thus, the user overviews the actual consumption, even though the main unit inside the timetable is time. One does not need any expert knowledge on watts and kilowatt hours. In addition, every device provides detailed information on its name, peak power, and average power. The energy sources show the user exactly where energy comes from at that moment and which devices it powers. It also shows the user if the battery is charged. For every energy source, there is associated detailed information, such as the expected production from the remaining hours of sunshine. The graphs summarize all of the above information and show battery level, production, and consumption. Underneath these graphs, there is a monthly overview. So, what are the features and interactions of the timetable? With double taps, the user can create time segments for a device. WATTIME now dynamically calculates how much runtime is available for this device in the current energy situation. This runtime varies according to how much energy the device uses. If there is not enough energy available and if the consumption exceeds the energy reserves, WATTIME shows how much the runtime of individual devices needs to be reduced to make this scenario work again. Thus, the user does not have to renounce television out of precaution. Because of WATTIME, one knows that it is sufficient to reduce TV usage for just a little more than 1 hour. During times of sunshine, a very variable amount of energy is produced according to the sun's intensity. This is why there are time frames in which some devices cannot be used. For example, the washer would cause a gap in energy supply when used in the morning. As seen before, WATTIME tells the user what to do to make the gaps disappear. The user now knows that he can either move the washer to another time frame, or he can reduce the light by about half an hour. The energy sources show detailed information about every available source. They also show lines connecting them to each other and to the other devices. These lines tell the user where which amount of energy comes from and where it is going. The user can grab and move the now line. The energy sources then automatically adapt the temporary time. In this way, the course of the day can be reviewed in time-lapse. The graphs summarize all the information from above. They show both recorded history and forecast data. The graphs adopt every change in the energy management in real time. WATTIME is the result of a widespread design process with self-experiments, co-creation, and prototyping in various iterations. Its biggest benefit is that the estimation of energy consumption is no longer a fuzzy undertaking. Create a detailed energy management plan without any expert knowledge. There is no need to reduce consumption for reasons of precaution. Every deficit is calculated as accurately as possible, and you see exactly what you need to do. Use energy from all available sources in the most efficient way. With WATTIME, there are no bad surprises like blackouts, and it is not another smart home toy that just eats up your time. Your home stays a place to rest. WATTIME. Smart energy management made simple.